Hey everybody, this is Larry. This is day 27 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Today is Friday here in New York City. I don't know. I'm always a little bit tired. I'm actually trying to rest up because one of my personal challenges this week was going to be I was trying to run 6 to 8 miles every day, 10 to 15K or something like this. I know I've been talking about running a lot. Maybe it'll be for only a couple more days. But basically, instead of doing that, I was like, oh, let me just sign up for this last minute half marathon, which is 13 miles, which is, what's that, 21K? So now I'm like, okay, well, I have to rest my body a little bit, so that's what I'm doing today. But instead, because I'm cheap and trying to save a couple of dollars, I walked to pick up my my bib. I don't know where it is. It's fine. I walked to pick up my bib, and it was like an 8 mile walk. So yeah, I did save the money, but now my knees are a little bit sore. So we'll see what happens. Hopefully, I'll get good sleep and stuff, and it'll be good. But yeah, all right. Let's take a look at today's farm, and apparently we'll go on a trail, so let's take a look. 514, Freedom Trail. Okay, in the video game Fallout 4, the quest Road to Freedom requires players to reach a metal dial called Freedom Trail ring and use the dial to spell a specific keyword to open the door. Let me pause for a second. I know that I've already done the intro, but I've just watched the Fallout TV show on, is it on Amazon or something? I forget what channel it was. Or what service it was. But anyway, the show was pretty good. And I don't know, let me know in the comments if you watched it, because I liked it. I mean, I have not played Fallout 4, but I have played 3, mostly complete. I had this issue where I used to play on the Xbox 360, and then the game, like the save file corrupted, and I just never finished it because I was like, I put like 80 hours in this. You know, this was a long time ago, but I put 80 hours on this. I'm not going to start over, and I never did. And I also played the first one way back in the day, when, you know, I barely could get the game running on my computer. But yeah, so definitely let me know in the comments if you're a Fallout fan. Did you play the video games? Did you watch the movie? Oh, not the TV series, and what do you think of it? I thought it was pretty fun. The TV series, the games are fun too, obviously. I mean, I spent so many hours, but I just don't want to invest time in the newer ones anymore, just in general. I don't play that much video games. Maybe, yeah, but that's besides the point. Except for Slay the Spire from time to time, but I haven't touched that in a while either because it is too addictive. So anyway, all right, let's actually get started this farm. I don't know, I saw this. I mean, it is kind of topical. Like I didn't just randomly bring up Fallout, but it is, I don't know, maybe that's why they made it a daily farm though. So I don't know. It is a hard farm, so we'll see how hard it is. Alright, so given a string ring that represents the code engraved in the outer ring and another string key that represents the keyword that must be spelled, return the minimum number of steps to spell all the characters in the keyword. Initially, the first character of the ring is aligned at 12. Okay, so it looks kind of like this. We have goddamn, so you run G and D, so the first character is at G, so it's already in place, so you want to move it to D. Why is that 4? One more step for spelling? What does that mean? Maybe I should finish reading this. Okay, so we could, one step is rotating clockwise, counterclockwise. Oh, you have to press the spell button to spell. Okay, so that means that you're at G. Oh, I see. So you click on G, you click on spell. That's one step. You go 2 to the right, and then and then it becomes, and then you have to click one more for 4. Okay, that makes sense. Yeah, I mean, with what was I gonna say? I mean, I think there are a couple of ways you can think about. I don't know why this is hard. I think that's the part. I'm just like trying to think what would be a hard way to do it. But I mean, for me, this is, I mean, maybe you could say it's dynamic programming, but not really, right? Because you have to end the last thing at, there's only one, because you have to do the key in order, right? There's no like, There are no choices at all in this problem, so I don't get what the hard problem is. I know I do get that this is an older problem, and an older problem, maybe it was hard back then, but I still don't really see any way around it, right? Because there are no choices. You just have to go from G to D, and there's only really two ways to go. You go left or you go right, and each of them will give you a distance, and then you just take the shortest distance. So, very odd. Ring is fine. Ring is duplicate. Okay. So I mean, I think the first thing I would do is to just create. How would I want to do it? I mean, I think it's honestly pretty okay either way. There's so many ways to do it, but even seeing the ends, if you will, whatever you want to call them, like the length of ring and the length of key is less than 100, even makes it even, like, you could get away with a lot of whateverness, but I don't even think it matters that much, right? So yeah, because I think the way that I want to, there's certainly a lot of ways to write it. So I'm gonna just I'm probably gonna just use the shortest path and then just do for loops. And the shortest path I'm gonna use is gonna be Floyd-Warshall, right? I'm just trying. I don't know. Okay. I mean, I thought there'll be and here the idea here is just to create a 26 by 26 distance matrix is what I want to start off with. I'm gonna start everything with at infinity. They just say A for alphabet. I don't know. Maybe that's. And then infinity is some big number, doesn't matter, right? And then maybe, yeah. Oops. Right? And then now we can just write some stuff like, let's just say n is equal to length of the ring, or maybe r for ring, I don't know, right? And then now, so the current index, so current, I don't even know, it's just so silly, is equal to the ring sub I, right? And maybe want to get the distance from A, right? And then the next item is just right? I plus 1. We want to mod it in case we roll over, right? And then that's just it, right? And then we just set up the distance. We would even set it up backwards. I guess I can just write it here, actually, right? And that's it. I mean, and you could also just look at it backwards, but that would be the next. Like, we look at it backwards, this is just going to do it, you know. There's some symmetry here that makes it right. And then you just do Floyd-Warshall, right? To get all the distances. And you don't even need to do so much, to be honest. I think I'm just over pre-optimization, but it doesn't really matter either. Right? And this is, like I said, this is Floyd-Warshall, so yeah. And then now we have all the distances, and then now we just have to figure out the steps, right? So, or is it steps or what they call it? Right? And now for I in range of, oh, I think I did this wrong. I mean, that's what I get for making fun of it. I mean, I think technically it is right, but it's not precise. I did this wrong though. It is very wrong. I did a lazy reduction and technically it's true, but it is not actually, because the slots matter. So okay. Yeah, okay, yeah, okay. I have to rewrite this. Sorry, friends. How do I want to rewrite this? Okay. Well, I mean, I don't think it's hard. It's just hard because I wanted to make it more optimized, but you can't do Floyd-Warshall. So basically what I want to do maybe then is just write, and to be honest, the Floyd-Warshall is even necessary because, like I said, this is 100, so you could have done something n square, right? I wanted to avoid n square and get it nailed to alpha cube just to be a little bit cleaner. But that said, like you know, if it's clean but wrong, it's not clean enough, right? So yeah, my apologies there. Wasted a little bit of time. Oh yeah. So the reason why this is wrong, and I kind of didn't. I think I was just doing shortest path on the characters, or the alphabet, but which has some basis, but it's wrong because, for example, after one spin, it matters. Like in here, for example, it matters which D you're in, right? Like if you're here, it takes 2 to get to I. You're here, it gets 1 to get to I. But the way that I set it up is because I just go from D to I, which is not correct. So the way that I would set it up, maybe instead, is yeah, I mean it's still n times alpha, so I think that's fine. Maybe not. Maybe it's n squared. No, I mean, yeah, I'm trying to like be a little bit lazy, but maybe not. I mean, you could have also. There's so many different ways to do this one. Because I'm trying to do it the shortest path pre-processing, but you could have also have done it with minimal pre-processing and then binary search, for example, right? But all right, it's fine. I think what I'm gonna do is just keep track of the indexes first, and then yeah, let's do it that way instead. I think I tried to be too cute, too clever, too smart. And you know, smart is fine if you could get it to work, but you can if you're wrong, then it's not, right? So yeah, for index C and enumerate the ring. Right. So then now you pre-process all the things, right? And maybe we'll just convert this to. Do I want to? Yeah, I guess I don't need to anymore, to be honest. Right. But yeah, this is the same idea basically. And then now for C and key, right? We start off at where do we start? Do we just start off the first character? Is that it? Yeah, okay. So then the first character is going to be 0, right? And then now we are at 0. It doesn't, because only the index matter, not the character, right? And then now we have to go to from the current index to any C that is near it. And in that, we just go to index of C. Here it connects all the index, and then we just binary search, right? Current. So this will give us the next the index that is closest to current without going. That is greater than or the next index that is greater than or equal to current, right? I just call it index because I don't know. I just convention. And then now index C sub C of index. Well, it has to be within thing. So if it's past the last thing, then it's out of bounds. So let's just say if this is less than that, then okay. So distance, let's just say that's equal to infinity, and then here. So basically, there are 2 ways to go, right? That you can go left or go right. So that means that if you find the thing, then it is yeah. So basically, you're at the current place. So if you binary search for it, this is the next that is less or that is equal to or greater than. So this is the next distance, right? So distance is going to be min of distance, which is infinity, so it shouldn't happen. The index. So this is the index minus current. It should be greater than, so that should be fine, right? Yeah. I want to do one more thing, but I mean, I think I have to add 1 for the button, but that's fine. And then if index, and they say that they guarantee that it can be done. So yeah, so that's fine. And then yeah, if so this is for the next the one that is greater than or equal to, but it also means that if index is the last element, that means that the first you want the first index. So we can definitely do that, right? So that means that the else is that now we want the first index. So yeah, but then now of course it's gonna be current. Oh wait, no. I think it's something like this plus the length of the ring minus current, right? Because basically you're wrapping around, because in this case you're going right? So this is for, and I say going right, I don't know if this is clockwise or counterclockwise, but you're going right from left to right, so right. And this is going left. And current minus. I think I have to be a little bit careful about all these though. I mean, it should be good, but I worry that, like, I don't know, this may return, like some stuff may return negative for some silly reason. And then now this is wrapping around, so this is going to get the last item, right? So then current step minus right. And then now we add 1 for pressing the correct button, and steps we add distance, and that's it. Hopefully. This is very awkward. I did this in a very awkward order. My apologies. My first impression. Yeah, that's what I worried about, negatives. But am I doing it wrong? It shouldn't happen, but. Oh, I don't update current. Though that still shouldn't happen. It should just be wrong. So I don't know. That's weird. Oops. Yeah, I think I have to also set. I didn't do this, but I think I need to set it up here, right? So next current is you go to index. But I mean, I needed this anyway. But there is something very awkward. I mean, it's still wrong though, is what I mean. That's the awkward part. I guess it's very awkward when it's wrong. But oh, and I still didn't use it. Okay, but why is that wrong? Let's see. So okay, print c distance steps. Should be an easy debug. G is 0. Did I do this wrong? Negative 12. I mean, it would be min. Why do I get negative 12 though? Current is 0. Alright, let's take a look. Zero and 6. Okay. So 0 minus 0 should be 0, which is great, right? So one of these maybe. But index is 0. Oh, I minus 1 is greater than you. Otherwise, well, this is. Did I do the sign wrong? Okay, so the last one's going to be 6. Oh. It should be this. I think I messed this up. It's still wrong, but I think I pressed the button an extra time or something. I don't know. But it's much more reasonable if nothing else. Okay, so steps is 1. That is what I expect. D from we don't need this for a little bit. Next one. From 6 to 3 should be 3, right? But well, we shouldn't go to 6, so I think this is just wrong. Oh, I'm just being dumb. I'm being dumb. I'm just having one of those days. I'm sorry, friends. What's wrong is that I look at this and then I update next current, but that's not right. Next current is only updated if the min is correct. I don't know what I'm doing. I wish there's like a min if function or something, so that like, cause I feel like this, like I feel like this gets used, or the way that I feel like I write this a lot, is what I want to say, and yeah, I think I just need to write this next way. So next, so for yeah, it's fine. I think this is fine. But it's just so much more code. And also I got the signs wrong now. I just realized. No, you want to update this if yeah. Oh. Actually, wow. I am really wrong, am I not? I have to redo this. I just realized a bug that I didn't realize. Which is that, oh no. I thought I could do greedy. I'm very wrong on this one. Wow. I guess it is hard. I got fooled by not thinking through the cases. I just thought it would be straightforward. But the idea here is that, okay, let's say, or like a tricky case is that, let's say you have a ring that is, I don't know, A, B, C, D, maybe also backwards, right? Oops, how did that happen? D, C, B, A, right? Like, let's say you have this, right? And now on the left, this is E and this is F set. And now you're trying to do A, B, C, D, F. Well, if you're lazy and greedy, you could just do A, B, C, D, and then this F, but that's not minimum, right? Because you go A, like if you go to the right, you go A, B, C, D, and then you have to do another one. So you skip the E to get to the F. But obviously the correct way is actually A, B, C, D, F, right? So that means that because the reason why greedy would work, not for this particular problem, but in general works, is because of well, I mean, one of the cases where greedy works is that there are no decisions, right? And I think I mentioned this in the beginning of the video, and I thought, oh, there are no decisions. You just kind of go to the next thing. But here there is a decision, right? And this decision isn't even. I think that's. I just kind of messed up on this one. I mean, it kind of tied into how I did it wrong with the Floyd Warshaw, is because I assumed that there were no decision, but then I kind of, I don't know. I think I'm just, I was too arrogant about this problem, and I just thought it was easier than it should have been. But that's why I was okay. I got fooled by this one. Not gonna lie, because I even in the beginning I was just like, why is this so easy? I don't get it. But there is a decision, right? So it matters which B you go to, right? I mean, I think now, I think I just tried. I mean, the dynamic programming is actually pretty straightforward, to be honest. But I just thought, I think I was just confused why. And I think some of it is that, the last couple of days is dynamic programming, which is fine. But this is also why I don't like these deemed weeks, right? I mean, on one hand, you do get good practice on certain type of problems, but on the other hand, the biggest part about practicing about these problems is recognizing them, and this really takes it away from them, right? I mean, I kind of ignored it anyway, and so it was fine for me. But yeah, give me a 5-second pause. I'm just trying to get water. That's what I was kind of edging away from the screen for, because after this I had to take a break. I hope that makes sense. I mean, not a break, but. But okay, let's reset our minds, refresh our brains. Apologies for, But yeah, I like to do these live, and I don't pretend I'm perfect, and I don't need to look smart. I know who I am. So yeah. Okay, so how do we want to do this? I mean, the dynamic programming is pretty straightforward in the sense that n is 100, right? So There's really not that much to do about it. I think there are a couple of ways you can play around with this. You can say, and there are other decisions, right? The decision is about which one to go, which is, I don't know, right? Like, it's fine. It's fine, but you can also imagine building a case where there's like a B over here, and then you do, you know, C, D, F, or whatever in the same case, and like a Y here, and maybe, actually in this case it doesn't matter, but you can imagine cases where you actually would choose a different B, and not just like in my other example. So then here, I think I do still want to pre-process it in indexes, right? I guess I shouldn't have removed this one, but that's okay. What am I doing? Wing or key? Wing, right? Yeah. Oh man, I was way wrong on this. My apologies. But this is where we learn. This is how they get you. That's how they fool you. Greedy problems, always tough. And I thought sometimes you even think they are, and then I'm like, oh. I was like, why would the bounce be so low? I guess so. But yeah, this is where you learn is from mistakes. Just typing it in is, you know, maybe it gives you the idea of learning, but you know, okay. So then now we have the way that I want to construct this dynamic programming. I'll do it with memoization, right? And like I said, it is kind of straightforward in a way. I mean, maybe it's not perfectly so, but the idea here is just that, okay, let's just say we have, I don't know, find min, is it? Find min. Terrible name. But you have index for the number of number of keys we have left to do, and then maybe just where we are in the location of ring, right? So then maybe index location, right? Something like this. Let's just write it out. Index is key sub index location. That's terrible. Is what is the next thing to hit on index, and then location is just where are we on the ring, right? And then of course, if index is equal to k, then we can return 0 because we're done. Otherwise, now we are currently at location, and we're just trying to go through. And there are a couple of ways you can do this. The reason why I pre-process is so that it's slightly faster. You can just do a for loop, right? And just do, but I don't know. Maybe that's still. I mean, it is still the same complexity, but it's still, this is going to be faster. And then basically just looking for the next one, right? So we're currently at location, and we're trying to go find a character that is key sub index. So okay. So, and key sub index is going to be in this thing, right? So then now for next index in this thing, because that's the next index we're trying to go, right? So then best is equal to infinity for whatever, and then best is just equal to the min of best, but then now going to this next index. So what's the so then now that's going to be find min index plus 1. The next index is the location. What's the cost? The cost is going to be the two things, right? It's either the absolute value of location minus next index. That's the shortest distance, or so it's like this, or if you go the other direction is what I wanted to say, which is one of the two ways, which is location plus, is it R minus next index, or next index plus R minus location, something like this, right? Basically it just rotates around. I think that's right. Maybe I'm missing one. I don't know. I'm really bad today, so don't listen to me. And then now we can return best, and then we're done, kind of. I mean, maybe, right? Let's give it a spin. Yeah. What silly mistakes? Keys, string indexes must be integers. Indices of keys P sub C. Oh, the C is not a thing. Key sub index. I don't know. That is very weird, actually. Okay. Oh, I forgot to add +1. Because you have to. Yeah. Okay. That's actually, maybe it should be here instead. +1, right? Because this is going the time to go to that location, and then +1 for the thing, right? And there you go. Of course, this being dynamic programming, this branches out way too many times, right? So we have to add some memoization. Well, what are the time complexity, right? Right now, is that index goes from 0 to R, no, 0 to K, and location is 0 to R. So total time complexity is going to be equal to total number of inputs times time per input, right? And yeah, and total number of inputs is just going to be K times R, and each input takes this amount of time, which is O of K in the worst case, right? So then this is going to be O of K squared times R, right? Which for 100, it's going to be just 100 cubed is the idea. And okay, so then let's memorize this, and it's pretty straightforward to memorize, right? The idea behind memoization, as I always say, is just that every input that you put in, you get the same output, right? Yeah, and so we can do that. So, oh, what am I writing? I've been writing this in a weird way today. I'm just really bad today. Which one is on the outside? Location, so that's ring, right? Right, and then now we can simply go, if we have cache for this input, well, if we have it, then let's return it. And if we don't have it, let's calculate it and then save it. Oops. And that's pretty much it. Well, if I type it correctly. That should be the idea, right? And let's give it a submit. Hopefully I don't make a... Oh, I have done this before, apparently in C. Yeah, I mean... How did I do in C last time? I did do it with the dynamic programming last time. Okay. Oh, and okay. And I didn't... That makes sense, actually. Damn it, silly Larry. I don't know. Maybe the Larry from 4 years, 11 months ago is smarter, which is definitely possible. I mean, I don't know. I just thought I don't know. I don't know what else. Some days your brains don't work. This is why you have to eat well and sleep well. but yeah. Oh, the thing that I wanted to say with this one is that the key thing, I mean, we've said it a couple of times the last couple of days with dynamic programming, and a lot of it I did it straight up bottoms up, right? And with this one, if I maybe have identified correctly in the beginning, I would have done it this way, but by then I was just like, okay, this should be good enough anyway. But yeah, the thing to notice is that for every index, we have index +1 as the next step, right? And you kind of go backwards as well, index and index -1. In that case, you can rewrite this as bottoms up and then use space optimization trick on it. I mean, it's not really a trick, just like a technique, an idea. And that means that you could, right now, this is O of, this is time, this is O of K times R space. You can actually reduce this to O of R space with space optimization. Yeah, and that's pretty much the idea. I think one thing to kind of what was I gonna say? Man, I'm just really blanking out today on things. I don't know. Maybe I'm just really. Also, has Fallout 4 really been out that long? 5 years ago? Huh? When did Fallout 4 come out? I am just curious now. Huh? 2015? Really? 2015, really? That's 9 years ago? I mean, I know that they came out with other stuff, but I think I'm just, oh, which one is 404 again? I don't, I'm old. 2015, wow. That was quite a year for me, actually. But, anyway, that's all I have for this one. Let me know what you think. Let me show you all the code. Here's the top, here's the bottom, and you don't even need to do this caching if you don't want to. I think it just saves a little bit on time. You could just do a for loop through every index anyway. But yeah. Oh, one more thing that I want to add is that one more thing that I would add is that in the worst case, it doesn't matter. But for this particular problem, this particular solution, this is I think we get often a lot. I get often asked about what's the difference between top-down or memoization or bottoms-up tabulation, right? And there are times where the top-down is more efficient than bottoms-up. Maybe not this one still because of the space optimization idea, but the reason why this could be, though, for certain type of inputs is because not all the states are reachable, right? And what I mean by that is that, and I think with this particular problem is actually there's an easier visualization on it, right? Because basically the idea is that, okay, we already assume that the location we're at was where the last character was, right? Meaning that, okay, let's say we're at what's it, Guarding? If we're at this I in Guarding, we know that the previous location has to be a D, right? And inside the ring, there are only 2 Ds, right? What does that mean? Why? What does that mean for us in the context of what I just said? Well, that means that okay, let me write this out so that we can visualize this a little bit. Let's just say we have, I don't know, I'm gonna change it. All right, so let's say ring is equal to Larry, and the key is, okay, Larry is dumb. I don't know, because that feels like today. All right, maybe I think we need both. But in any case, right? So let's say that's the ring and that's the key, and let's say we're at the Y, right? So that means that if we're at the Y, MCA. Man, my brain is doing very weird things today, so my apologies. But let's say index is equal to 4, right? Is it 4? Yeah, no, Y. Well, the location can really, we only could come from this R or this R, right? From in the ring, right? So that means that the location can only from 0 to 3. What does that mean? This is just an example that if the index is 4, location can only be 2 or 3. And not every possible, like, so it cannot be 0, 1, 4, 5, ... right? And because it cannot be 0, 1, 4, 5, then you skip doing all this work for those cells, right? And you don't even look at them because we never even think about them. The code just doesn't call into them. So that is one example of how top-down memoization is more efficient, or just runs faster, or as they always say, that's when top-down does less work than possibly tabulation, depending on the input texture, if you want to call it that, like the input distribution, right? Of course, even on bottoms up, you can construct, for this particular problem, it's easier to construct a bottoms up approach that cares about these constraints in a good way, right? Because you know that, like for this example, you know that for this index, these locations cannot be true, or these locations cannot be true, and it can only be this location. So you could pre-process things in a way such that the bottom up, you can only care about these things. But I just want to give you an example where this is the case, and there are other examples where it's just way harder to construct that set of, like, in an optimization problem, there's all these constraints that you have to, abide by. And it's just very hard to do it on a bottoms up, where you have to know where each cell is possible or not without doing additional work, right? And we do that additional work, then you might as well just visit the cell almost, kind of, sometimes. Where if you do top down, then you just never visit them. So you have this branching tree kind of thing where some branches just never get reached, right? And that's basically the idea. I just want to kind of, and I just noticed that this is a good example of that kind of thing. So I just want to, illustrate that for people who might be beginning. But yeah, that's all I have for this one. It should not have been 40 minutes. I did add a lot of, just additional fun things about memoization and dynamic programming, but still, that's all I have for this one. Let me know what you think. Thanks for watching. This is recorded live, so you get to see all the silly Larryness and all the mistakes and the recognition of whatever. I'm going to eat and sleep. So thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.